Recording now. So, hi everyone. Welcome to the sixth workshop of the semester. This is the 3D printing workshop. It is March 10th, 2023. In this workshop, we'll cover some fundamental things about 3D printing, a really, really cool manufacturing tool that a lot of us use in our daily lives to prototype things. It's becoming more and more common as the years go by. So it's a very exciting form of technology you can use for rapid prototyping and rapid engineering. So, first we're going to be talking about 3D printing in a nutshell. If you've never heard of 3D printing in your life before, well, welcome to this workshop. But secondary, what is it used for? So what is 3D printing? So there are a lot of different types of 3D printing in the world, but the most common is known as something called FDM, which is fusion deposition modeling. It's when you have a huge reel of plastic that feeds into a machine and the machine deposits it onto a bed, and it just goes around in many shapes that makes up your drawing. So every layer gets deposited on top of each other. So if you can think of anything you want to print, slice it into like a million different layers, or not a million, that's an exaggeration, but a lot of different layers. Every layer that gets stacked up of each other gets printed by this machine, and you get your full model. So it's depositing plastic onto the bed and generating your model in that manner. There are a few different types of manufacturing. Well, I only have additive here. This is a type of additive manufacturing in which, in order to make what you want, you have to add things to your model, right? So in this case, you're adding plastic onto a bed. There are other types of modeling that are in the realm of 3D printing, but they are subtractive modeling, so we'll talk about that later. So the reasons for 3D printing really is if you want some thing made for your project, like a case or some structural components or something for like an electronics case, like we've done in the PCB design workshops a few weeks back, where we talked about electronics modeling. If you want to, let's say, take your project to another level and make a model or something to mount your PCB onto, then you can do it using 3D printing. But in other means, if you just want to make a robot, if you want to make some functional part of your project, you don't have to cast in plastic and make it like official. You can just buy like a $100 machine and do it yourself. So it's an easy way of making prototypes. But the downside of 3D printing is that it usually has long print times. Now, as I said before, this type of technology has evolved over the years. Back like 10 years ago, a single 3D printer like you see up here would cost you over $1,000. Over the years, that has gotten way, way cheaper. This is about $200, $300 now, and it's relatively inexpensive and it's for hobbyists. So the worst thing about 3D printing is that it takes a long time. But recently, companies such as AnchorMake and the Bamboo X1 Carbon have been working to make printing faster. And currently, our printers can print almost 5 times as fast as the previous models that you see up here. But you can also do mass production with parts, with an exception. If you want to mass produce parts, let's say you're making a 3D model of like Baby Yoda, for example, and you want to sell it on campus, which means people love Baby Yoda, so they're gonna buy a lot of it, and you wanna mass produce it. You can do so with a 3D printer, but you do know cost-wise, at some point, it's easier just to like order it wholesale from like a distributor. But if you want to 3D print it by yourself, you can do so as well. So in consumer electronics, where I come from, where my background is, it's really useful for me to 3D print items because I can get it almost like in a day's notice, right? I design my structure for it, and then I put it in my slicer and I put it in my printer, and then I get to test it 8 hours later. Back then, before we had 3D printing, what you would have to do is you have to contact a company that does this kind of manufacturing for you. It would take 1 to 2 weeks, and then after that 1 to 2 weeks, it would take another 1 to 2 weeks for shipping. Basically, it would take a month for you to get your part back, and by then, you may have already lost interest in the project or moved on to something else, and just like essentially not have your end goal in mind. But with 3D printing, it's pretty much, comparatively to the month's notice, it's pretty much instant. So that's why it's the best, right? So consumer electronics just represents the portion of engineers like us, like hobbyists, that do this for fun and not officially. But even in like the industry, if you go and go do an industry-related job, even they use 3D printing a lot, unless they have a lot of money in which they have more expensive machines to make things. 3D printing materials. Okay, so when you're 3D printing, especially using something like an FDM, you can use a lot of different types of materials, like plastics, in order to make your model. So the most common material you will use in your 3D printing is known as PLA. This stands for polyethylene acrylic, maybe? Just kidding. Polylactic acid, yes. I was thinking of something else. But this is the most common form of 3D printing material. It's biodegradable material, and it's relatively safe. So it's good for consumers like us. You don't have to have like a surrounding that prevents this material from being, you don't need an enclosure is what I mean. Because some of the other materials we're going to be talking about are a lot more dangerous and hazardous to our health. ABS, oh, perfect. ABS, I don't even know what this stands for, but it's probably the most dangerous consumer electronic material that you have there. This is hazardous to your health. When you print using ABS and the plastic melts, it releases harmful particles in the air that when you breathe in, it would damage your lungs, which is why when you print with ABS, a lot of the times it comes in an enclosure, which means that there's a little box on your printer that exhausts or that takes the harmful particles and pushes them like to another place, like outside your house, right? But the benefits of using ABS is that it's structurally a lot stronger than PLA. So if you want strength in your prints, maybe if you're doing something like this, where you have a lot of gears and they're intertwined with each other and you want them to last for a long time, you would use ABS instead of PLA. But again, just if you're printing with ABS, it is a little bit dangerous and you do need an enclosure. That's the takeaway you should get from this. PETG or PETG is kind of like if PLA and ABS has a baby, right? It's kind of like a mixture of the two, the best of both worlds. And it's also safe, but stronger than PLA. So if you want a simple description of what PETG is, just stronger than PLA, not as dangerous as ABS. Kind of like the middle. TPU, oh, this one's one of my favorites. This is bendy plastic. So if you want to print with TPU, you're usually doing it for vibration dampening mechanisms in applications, or you just want to make like a phone case, right? If you want stuff to bend after you finish printing, you make it in TPU. And it's not dangerous like ABS. You don't need an enclosure to print this in, but you do need a direct drive extruder. A direct drive extruder is when a 3D printer pushes filament out like on the gantry itself. The gantry is where the nozzle is. So if you think of when you see a 3D printer and the nozzle just move back and forth, that's where the extruder is. There's two types of printers, one called the Bowden tube printer, where the extruder is like to the side of the printer so that it has to push the filament a long ways until it gets to the nozzle, or you have direct drive, in which the extruder is like directly above the nozzle. TPU is bendy, so you're not going to be able to push that long string of filament through using a Bowden tube. So for the most part, usually you need a printer like an Ender 3 S1, or you need to modify a printer for it to have direct drive in order to get the TPU consistency right. Just remember that it bends and whatnot, so it's a little dangerous. Nylon, okay, so you probably won't print with nylon ever, but it's a lightweight material and it's a complex print structure, which means that it generally does not, it's not as heavy as PLA. So usually if you're trying to make something like a plane or like a VTOL or like a drone or anything that you don't want to be too heavy, you can use nylon as a substitute. And then PVA, this one's a fun one. PVA is soluble in water. And so it's substance that when you print it, it's usually used for dual extruder printers where you have two extruders instead of one. So with dual extruders, you're able to you're able to print the supports in PVA and the main component of what you want to print in like PLA or something like that. And then what you do is you dip it in water because then it would dissolve away all the support structures and you don't have to remove it by hand. We'll talk about supports later on. And you also have your composites like carbon fiber, Kevlar, and fiberglass, but those are actually really difficult to print. Cal Poly Pomona has a carbon fiber printer. It's like $10,000. They also have a metal printer, which is also $10,000. So as for consumers, I won't touch on these a lot, but they do have special properties that allow for more complex engineering applications. So this is the most important part where we talk about 3D printing safety, right? All right, so when you're working with 3D printers, you want to make sure your printing area is well ventilated, especially if you're printing with ABS. But if you're just printing with PLA, you don't want to like stand next to your printer huffing the fumes. It's not that safe for you. Oxygen's way better. But still, you want to make sure when you're printing, you have some sort of ventilation, maybe like a vent, open vent in the ceiling, or some other similar solution like that. Because otherwise, your lungs will get irritated after a while of working in this situation. I would know because I have a miniature print farm that I go in and print in a lot, and I always get some sort of like irritation afterwards when going in the room because of all the particles that are in the air. So this point is especially important if you're working with ABS, but with PLA it's not as dangerous. Yeah, some materials are toxic in small environments, including ABS. Okay, next point is keep your hands away from the nozzle and other tight spaces. First point is the nozzle gets hot, and it gets about 200 Celsius degrees hot, which is about like almost 800 Fahrenheit. It's nuts. Like, I've burned myself by touching the nozzle before, and I want to protect you by telling you that you should not get your hands near the nozzle. Now, there's an exception to this rule. During the escape room, one of the things you're going to do is installing a new nozzle. Now, installing a new nozzle on a printer happens because of a couple reasons. One, when you're printing, your filament gets stuck in the nozzle and doesn't want to go through. Two, when you're printing, you notice there are some defects in the flow or how much plastic is going through the printer at all times. Three, you're being placed in an escape room and you want to use the nozzle to help you escape. That last one's very specific, but nozzle replacement, and if there's one thing I want you to take away from this workshop, is that you want to install your nozzle when the hot end is hot. You want to remove your nozzle when the hot end is hot. Because what you don't want to do is you don't want to remove the nozzle when it's cold and the nozzle's snapping on you. Because the nozzle is made of metal, and this metal is kind of brittle, right? It's not the strongest thing in the world. So when you are installing or removing a nozzle, make sure the hot end is preheated to like some high value like that. And you're gonna probably ask me, if I want to keep my hot end hot while installing nozzle, like you just told me to keep your hands away from the nozzle, so isn't my hands going to be like relatively close? And yes. So what you're gonna do during the escape room, and by the way, each escape room is going to have one person, known as the game master, who knows how to work with 3D printers and can help you solve any problems and to keep you away from danger. When you're installing the nozzle, you're going to twist the nozzle onto the hot end when it's cold so that it's like comfortably on there. And then you're going to preheat the printer to 200 degrees and then tighten it the rest of the way with a wrench or pliers. This way, what's going to happen is that the hot end is going to mesh with the metal on the nozzle and form a really tight, secure bond. Because what's going to happen is you don't want it falling off mid-print. So you want, when you're tightening it, for it to be hot, because when it's hot, metal expands. And when it expands, it allows you to push it in further than when it's cold. So that's just my 2 cents on nozzles. The second thing here we have to talk about is other tight spaces. Now, 3D printers are made of stepper motors, or stepper motors move the 3D printer from one location to the other. So it'd be really bad if the stepper motors were moving and you put your hand inside and it just squished your hands a little bit. Stepper motors don't come with the safety of knowing when to stop. So if you put your hand in the middle there and the stepper motor moves onto it, it's not going to stop. It's not going to have any care for your squished fingers. So be careful when the printer's moving. Try to keep it away from tight spaces if possible. Yeah. Oh, yeah. Nozzle can heat up to 220 Celsius, which is more than enough to burn flesh. Now, if you're touching it for like an instant, you might get a small first-degree burn. And I've done that before. It hurts. So be careful. But if you hold it down there for like long enough, like it's gonna cook you like meat. And I'm not joking, it actually will, like, it can cook your skin. So try to avoid putting it on there for long periods of time. I mean, not that you would want to, right? If you put your hand even there for a second, your pain receptors are gonna go like, hey, you should probably like let go. Just a warning though. Yeah. So again, printers have many moving parts and stepper motors will crush you without feeling bad about your health. Okay, so this is the second slide on safety. Now here we're going to talk about clothing and other apparel. When you're 3D printing, you don't want to wear, well, you want to wear appropriate clothing. So as much as possible, you don't want to have like loose clothings lying around, or you don't want to have like open-toed shoes, or in this case, if you have open-toed shoes, you're probably fine, but I'm just saying different ways to keep you safe. Closed-toe shoes, I recommend in any instance. I mean, I don't wear them at home, but you're working with heavy objects. So if you drop like a 3D printer on your foot and you're not wearing a shoe, it's gonna hurt, you know. So that's that warning. You wanna tie your hair back so it doesn't get caught in the stepper motors and the moving parts. Mainly this is targeted towards people with long hair, but we do have hair ties in the room, I believe, if you want to stay safer, but I don't think that will be too much of a problem if you don't like purposefully dangle your hair in the printer, you know? Again, all of these are just like safety concerns I have to tell you about, but if you don't go extreme and you just treat the printer nicely, it won't be dangerous for you. Handle sharp objects with care. I have a partner, usually he's here with me, Sam. I don't know if you guys know him, but Sam usually does this demonstration with me where I have like this is a wire cutter. This is like one of the best wire cutters you have. It's very useful for 3D printing because it allows you to get places. And the thing about this one is you don't want to hold it by like the handle with the sharp points out, just in case Sam asks me for these wire cutters and I go to give it to him and I trip and stab him, right? And that might happen. So whenever you're handling sharp objects, what you want to do is you want to hand off sharp objects with the handle outwards. So you're going to grab the wire cutters with the sharp end facing you and the blunt end facing the other person. Because the worst comes to worst, you're going to stab yourself, not the other person. But just saying. And make sure you watch your fingers. These things are sharp. They're meant to cut plastic, and they will cut you. So make sure it's not between the blades when you're cutting it. And yeah, that's all I have to say about that. Okay, the most important point, I think, when we did this last semester, we actually built 3D printers. This semester, we're just going to have templates for you. But in general, if you want to build your own 3D printer in the future, it's really important not to over-tighten screws. When you're tightening screws and there's like 4 or 5 screws in a pattern, you're going to loosely tighten them all first and then go in a star pattern. Basically, you're going to tighten one screw first and then go in the other corner and tighten it a little bit and then go in the other corner and tighten it a little bit. And the main reason to do this is because of tolerances. If you tighten one screw like really tightly, the other 2 screws aren't going to fit, right? And so if you over tighten the screws, you might also strip the screw, which is also really bad because then you can't get it out. Stripping a screw is when you tighten the screw so much that it erodes the metal away from the top, basically preventing your screwdriver from accessing the screw anymore. So bad thing is to over tighten screws, but that's just a warning. You guys aren't going to work with screws today. Okay, printer calibration. One of the things you are going to attempt in this workshop is printer calibration. We are focusing more on troubleshooting here. The main part of this is a broken 3D printer. So you are going to calibrate the printer. Calibrating the printer. Sam's here. You want to talk about calibration?
Sure. Hi guys, my name is Sam. Nice to meet you guys.
This is Sam.
So we're gonna be kind of quickly talking about like calibration. There's a couple different things that like there's a reason why we do this. One of the main reasons is obviously the printer doesn't actually like know where it is relative to the whole thing. It only understands absolutes, right? So we level the bed to make sure that you have basically like an even distribution across the plastics when they are laid on their first layer, right? As you can imagine, for any kind of printer like an FDM printer, like the ones you guys are going to be using, you need to have a good adhesion to the first layer. If you get it too close, you're going to clog the nozzle because basically the plastic won't be able to push onto the bed. If it's too low, it won't adhere at all. There's kind of an art to it. There's easy ways to do it, but there's more manual ways to do it as well. So basically what you want to do is you want to set the nozzle very, very, very close, like to the bed. Me and Chris like to turn off the steppers. You can keep them on if you want, but you probably would need to turn them off in order to move them.
Some printers come with like a default leveling guide.
Right. Yeah.
Probes like all four
These
corners.
ones do. These ones do. So yeah, if your question, either way, you can use the default leveling probes. That'll set it to positions that are like kind of under where the screws are supposed to be. They're okay. I was just working with it. I didn't quite like it. I did the method that Chris is talking about. So you basically just turn off the steppers. There's a section, you just click that, turn it off. Basically allows you to move everything. Make sure you turn off the steppers before you try to move anything, because when the steppers are on and engaged, they're not going to try to move. And if you try to overcome that, that's going to be a problem. So hopefully, yeah, don't do that. And then you would adjust the knobs on the bottom. They're like these little screws. There is also the idea of bed probing, which is like what me and Chris and kind of everybody else who's like not insane does in this deal, where essentially you have a system where you know a distance between like a touch probe. It's like quite literally like just a switch that goes through and touches various points on the bed to basically give you like a variance across that bed. We call that like bed meshing. You can there's like different kinds of probe systems out there now. Like now there used to just be like just touch systems. Now there's like the system that I have on my printer is basically like an electromagnetic sensor. So that just basically just runs, tests the whole thing. It doesn't actually have to touch the bed. It's a lot faster and I can get much more accurate like mesh probes. But more money you spend, the better it becomes basically on a thing. So, but it's essentially just a system that where you know the difference between the absolute distance between the actual nozzle and the touch probe. That goes through and just tests it and then understands like what the deal is, like where it is basically. That's the cool way to do it. That's like the much easier way to do it. So, because you only really need to mess with it once, and then you're done.
Thanks.
Yeah.
So when you get good at working with 3D printers, you kind of develop muscle memory. So when we don't give you a bed probe, so it's harder for you guys because you have to manually like level and all. But for bed leveling, you can get good at like eyeballing how close the nozzle is to the bed on all four corners, and you can kind of just do it automatically. And so that also is the case for like feeling how high the nozzle is above the bed. When it prints that first purge line on the side, you can feel if you've leveled it correctly or not just by like touching the bed. I know like I advised against like touching the printer like while it's on, because you know the bed's hot, the nozzle's hot, but
it's like 60 degrees
Celsius. It's 60 degrees Celsius.
Don't touch the extruder. But yeah, touch the bed at 60 degrees, it's gonna be warm.
Yes. Yeah.
If it's anything higher than that, though, I refrain from touching it.
I will warn you that one of the thumb screws are the springs that are holding the bed up, will be completely removed from the printer in the room. The challenge is to find that thumb screw wherever it is, install it back on the printer, and level the whole thing again. So for the most part, the whole printer is going to be leveled except for that one thumb screw, but the difficulty is installing it. The printers you're going to be working on are JG Magics, which are kind of like the cheapest printers on the market right now. They're kind of bad. Enders are better, but we got these for free, courtesy of Spider 3D. So, yeah. So these are kind of bad printers, but you're only going to print one thing on them. So that one thing's got to be good.
Yeah, that one thing to get out.
Yeah, to get out of the room. So. Yeah, that's going to be the difficulty, and there will be a game master in each room that will help you calibrate the printer using that method.
I printed one of your keys online in 2 minutes.
Wow. Sam has a Voron.
Yeah.
It's super quick. The key is going to take 12 minutes for you guys to print, but for him it's like 2 minutes, so it's like 6 times as fast. All right. Real quickly, I'm going to talk about E-step calibration, although it's not very important for today.
Yeah.
E-steps are extruder steps. There's a whole process here, but for extruder steps, sometimes the extruder stepper motor also needs to be calibrated so that you know how much filament it's pushing at any given time. And that's basically it. So when you're dealing with like nozzle stuff, there's a lot of like things that can go wrong. Your extruder settings could be wrong, your flow settings could be wrong, your temperature could be wrong. Like there's a lot of variables that could go wrong in 3D printing.
It's pretty much just like you just guess and checking and kind of figuring it out. You really never have to touch these steps unless you actually start modifying the extruder in any way, shape, or form. So if you were to put on like a brand new extruder system, like a Micro Swiss or I don't know, Bondtech or a Mantis or any of those kinds of extruder gates, there's a million of them out there. But basically, you will have to change your steps. Because the E-step is basically just kind of telling the motor system, like, okay, this is how many, because the motor, again, doesn't know what a millimeter is, it only knows what steps are. So you basically have to tell the controller, okay, listen, this is like how many steps it takes to do 1 millimeter, like essentially. And we don't actually do that. What we normally do is we do 100 millimeters, and then there's a calculation you can do, and that kind of gives you the whole thing. But E-steps, if you don't do it properly, will result in some kind of print like that. That looks like it's under extruding.
Yeah, skipping some.
Yeah, skipping layers. That you don't want that.
Yeah. Basically, a summary on E-steps.
Right. I'll feel bad for anybody who ever actually has to do it. It's not that fun.
I will say I put this on here last semester when we were doing the belt printers, because for the belties, you do have to do E-step calibration. What you do is you print out a 100 millimeter long block cube, and then you measure it using calipers to see if it's accurate or not. If you guys didn't know, belty is what I call a CR30, which is a 3D printer that prints at a 45-degree angle on a conveyor belt. It's really cool. You can print basically things on a loop, right? So you can just press print. If it's perfectly calibrated, you can walk away for 2 weeks and come back to a pile full of parts. It's great. All right, real quick thing on calibration prints. When you first start using a printer, you got to print one of these things in order to make sure your printer is fully printed. It's kind of like a torture test, but for your printers. And in some case, the key that you're going to be printing today is kind of like a torture test, because you need to make sure your printer is accurate enough to get all those like little grooves on the key, right? So here are the different types of calibration cubes or prints. Each one of them has a different property that allows you to test different aspects of your printer. First one is the classic XYZ 20 millimeter cube. It's not printed here, but basically what it is a, oh, it's right here, just kidding. So it's a 20 millimeter by 20 millimeter by 20 millimeter cube that has XYZ on each end. And you print it out, it's like the fastest thing you've ever seen.
That is the most like thing on Thingiverse.
Yeah. And it just has like XYZ on each side for you to test if it can print those letters out correctly. I made my own with my logo on the side.
Yeah, my buddy Boxy made one too.
Yeah.
Test. He added like a bunch of new stuff into the tube that makes it more painful.
I made, so my logo has a lot of rounded edges, which is what I usually test. It has like overhangs, which are like a single dot. And so you can make your own calibration test if you know what you want to test for and you know what you want to optimize. 3D printers are a labor of love. You put more work into them, they give you better results.
Yeah.
Flow cube, this checks for accurate flow settings. I actually don't know what this looks like.
It's not actually a cube. So what it does is it creates, so that's like a Perusa thing. They like to do that. I mean, I never really did that, but it's like basically like if you want to determine the flow of your extruder, because like the thing is that especially if you want to get to the high speed stuff, you need to be able to, there's a lot of things that start to happen when you try to go faster, right? One of the big things that you have to consider is flow. If your extruder cannot keep up in terms of heating the plastic at an adequate speed while it's moving, right? Like, because think about it, right? Like if you're moving faster, you need to push more plastic per second, per time, or whatever, right? If your flow isn't high enough to do that, that's too bad, right? Like you're gonna have skips, you're gonna have jams, you're gonna have all sorts of stuff. You can crash stuff, you'll destroy gears, you'll do a bunch of different stuff if you do that. So try to determine your flow. If you bought a stock printer, chances are somebody probably already did the flow testing for that printer. So just refer to external results if you're having an issue, right?
Yeah. This is sort of more advanced stuff that you don't really get into as a beginner.
Yeah. Flows.
Yeah.
It's a good thing to test that.
Yeah. CaliCat. Oh, this one's my favorite. It's the cutest.
Yes.
It's this one right here. And it tests for a lot of things. There's a lot of overhangs on the side that are difficult to print. This little thing here is difficult to print. The face is difficult to print. Yeah.
I got a lot of them. Just they take up a ton of space.
I have a lot of benchies on my desk. Next one is 3D benchies, like one of the most popular prints ever. Like that's like the face of 3D printing.
Around benchies because it was created by a gentleman who basically wanted to kind of benchmark a printer.
There's a lot of features on there that test for like accuracy. Like this slope right here on the right is really hard to print because it's basically a whole overhang. And then like the top cover of the boat is also really hard to print. There's text on the bottom and on the sides.
Like the texture on the inside.
There's a wheel on the inside too that's just like hanging.
There are people, lots of people, well, you can go over to the next slide. I know what you're talking about. A lot of people, that's kind of the thing. Like if you go to somebody who's like an actual 3D printer person, you start talking to them about like different, like what is the best calibration, I guarantee everybody's going to say something different. Because everybody kind of insists or swears by their own deal. So just recognize the fact that if you talk to somebody who is like a jerk, they may be offended by the fact that like you assumed that like that, whatever the case may be. So just know that there are different calibration systems out there. The reason is because one person couldn't like agree thing with what the other person said. That's how it goes.
Yeah.
So the last one, I think. Yeah.
This one's fun.
It's really painful.
So when you get into printing things that are moving, or like at least things that print in one piece and are moving, you want to print a torch or toaster. This mainly tests for tolerance between parts. This whole thing is movable. Like you can press down the plunger, the toast pops up.
It should work off.
Yeah.
If you did it right. If your tolerances are good. If it doesn't, you suck. So,
yeah.
I don't think the printers we are giving you today.
No, they won't. They can print the keys, but they can't print this. Yeah. These are gears, so like if you unscrew it, like the back panel is like a tolerance test that goes from like 0.5 millimeters to like 0.1 millimeters.
There's so many of those to get that.
Yeah, it's painful.
I'm not
I have like, out of my arsenal of 15 printers, 4 of them can print this.
Out of the 2, I think only 1 for me.
It's 50% accuracy. Yeah, it's crazy.
Yeah. I think the other thing is that what the sad part is, I think the cheaper printer is actually the one that can do that one. The more expensive one, I think I'm running too quick.
Oh, I see.
Yeah.
Yeah, so the deal with this is, or the reason why we talk about moving parts is there's one puzzle in the room that is 3D, basically everything in the room, all the puzzles are almost 3D printed or have some relation to 3D printing. And one of the things is a movable part. It's a 2-part system. You'll see when you get to it. It's pretty fun.
Oh, yeah, and we'll show you actually.
Yeah.
Do we want to show
No.
the mistake?
No. Well,
later.
We'll show you later. Like after the escape room, we'll come back here and do like a roundup and
We fall
leave.
for our own problems.
Yeah, but yeah. All right, small note on printer troubleshooting. That's the main focus of today's workshop is how do you troubleshoot a broken printer? Because we're throwing you into a locked room with a broken printer that we've done things to, and it's your job to fix it. And fixing it will allow you to leave. Isn't that awesome? Adhesion issues. These are very, very, very common. Adhesion issues are basically when your first few layers don't stick properly to the bed. They're either too far from the bed or way too close to the bed, which is the worst because if you're working with things like glass beds or PEI beds, it leaves like a mark and it's like horrible. And you're just like, no, let me stop this. Because like you see like it just scratching across the glass bed because they're too close.
Crashed your screw into the bed and you scratched it up. Yeah, you don't want
it sucks, but it happens.
Yeah, it does happen.
So if your print does not stick to the bed, it's either because it's too close or too far, and it can be any one of these issues. So you can have a messy first layer, elephant's foot warping, it can be fused to the bed, or your material can be bad. Like if you print with like, if you print with like really old PLA, PLA has an expiration date, by the way. It's like snappy if it's old. So if you print with really old PLA, it might not be able to like print as well.
All plastics got an expiration date.
Yeah.
In fact, actually, some plastics got a much faster expiration date depending on what the deal is than others. Because the thing that makes them expire so quickly is they're porous. So we calculate basically like the porosity.
That's a fun word.
So like basically like how much it absorbs atmospheric water and other junk and stuff like that. If you leave it out for too long without vacuum forming it or cooking it or baking or whatever the case may be, you're gonna have bad plastic. I can show you a lot of rules.
It's like blobby. It's disgusting.
Yeah, and it snaps and it doesn't quite fit right. And I mean, that little robot that you saw a couple things back, that it's all bubbly. You can do that. Yeah,
I mean, all of this is just to show you how many things can go wrong with 3D printing. A lot of people have hot boxes or dry boxes that they put their old filament in to try to remove the moisture, and it works. And some people actually like just have the filament in the hot box while it's printing.
Yeah, that's what I do. Yeah, so my systems, I have a little Sun system that actually don't mind print. So one of them has a little hot box thing that's a separate unit. The other printer is so big that in reality you can just put the plastic in there, and the actual chamber itself being heated heats the plastic. I also have a system on board that blows hot air in to get the chamber to a correct temperature. Guys, it's a rabbit hole. So all to get just that perfect print all the time. But I mean, it's
that perfect first layer.
Yeah.
Yeah.
It's one man's dream always.
A note about first layers, actually. When you're printing, you want to keep an eye on the first few layers that you print. It's like, if that first few layers doesn't print right, the whole thing's going to fail, right? So whenever you're printing, rule number one is probably just to like look at the first few layers, make sure it prints right, and then you can leave. Unless you have like a lot of trust in your printer, in which I just let it go. But for like at least a new printer, make sure you look at the first few layers, because you don't want to come back to a pile of spaghetti.
Unless you have like safety measures put in place to stop that, I just wouldn't walk away. I don't care how confident you are.
Yep. Well, we talked about filament. If you have garbage filament, you get garbage prints. The more money you spend on this hobby, the better stuff you get.
Yeah. That top one can also happen because of mechanical problems.
Right, a retraction. If you don't have enough retraction on your extruder, what stringing is kind of like this picture down here. If you go from one point to another in the print and you haven't retracted the filament back enough, it leaves behind a residue, and it causes stuff like this to happen in your print.
That's why people do direct drive systems, where direct drive just means that the motor is sitting on the tool head, basically just pulling it out. The cool thing about direct drive is you don't have to pull it out nearly as far, but it's like, and not nearly like, and much quicker, right? The downside though is that you're adding more weight to the tool head, so you can't necessarily like throw the thing around as much, right? That's why some people sometimes opt in for what's called Bowden, right? And Bowden is the system that you guys are going to be using today, where the extruder motor sits. Where basically the motor sits on the outside off the tool head. You can run them faster, hopefully, right? And the problem is that you'll have to kind of be a little bit less forgiving with how quickly you need to retract and detract and everything like that, or bring it to the floor. So
yeah,
it just depends.
Big issues.
Bad plastic too can also be a problem for that too.
Well, about the bad plastic. I recommend you guys get quality filament. I made the mistake early on in my career in which I trusted Amazon Basic as my filament provider. It was actually absolutely terrible. Worst mistake of my life. Hatchbox is like a reputable company that provides good filaments. I actually have get my filament from Hatchbox primarily. I have a wholesale deal with them.
I have a deal with my guy.
Yeah.
Louisiana.
If you want filament for like relatively cheap prices, you know who to talk to.
Well, my guy ain't cheap.
Yeah. The average cost for filament these days is from like anywhere from $25 to like $50 for like really good quality.
35 a roll, that's good stuff.
Yeah.
And like just comes out perfect. I love that stuff.
If you get filament from Amazon, the most companies that people fall into are Amazon Basics, Overture Filament, and Sunlu. Amazon Basics is just the worst. Don't get it. Overture is good for their silk filament. I like their silk filament, but both Overture and Sunlu have a low shelf life. They snap really easily.
Sunlu makes really good equipment,
right?
But they don't make really good filament.
It's kind of like a company that has feature creep and decides to do something else, but they're not good enough at, and just
trying to break the mold.
Yeah, they're trying to get into the filament industry, and it's not working.
Try to order from the U.S. too.
Yeah.
Because U.S. guys,
This is a lovely picture. So print shift is the phenomenon in which if your printer decides to, or like your print bed slips to the left a lot, or your printer decides to have a mechanical.
You punch the tool head.
Yeah.
You just go like that.
Yeah.
Brought it back.
So print shift rarely happens, but if you're printing something really tall, or you're printing something for a very long time, or your machine isn't properly calibrated, it may decide to give you an offset in your print like that. And this has happened to me before. Beds can slip too. A lot of stuff can happen. You can have like less lubricant. Again, remember that the printer's homing sequence is like the only part where it knows where it exactly is. After that, if something else happens to the printer, like it won't know exactly where its location is, which in robotics, that term is called localization. If your robot doesn't know where it is in the world, if like something external happens to it, you're gonna get something like this happening, where like it just doesn't know where it's looking and it thinks it's in the right location. It's wrong.
What do you call it?
Localization. Yeah, that's.
I just called it absolute, like whatever.
Well, absolute relative, but like it's encapsulated between
Right, right,
local. Well, it's more of a robotics terminology
No,
for
I like-
control
I like the term.
systems.
I'm gonna use
Yeah. Yeah. So just remember that if you have a power outage too. I just had a power outage this morning. It was the scariest thing ever. I think someone in my house decided it was a good idea to turn the heater on, and because I had like 16 printers running at the same time, my breaker popped.
Oh, so it was your own fault.
No, like I was sleeping. I woke up to like all my printers dead, and it was like I'm not gonna be able to get stuff done on time.
Dude, just open your door.
Yeah, no, like the room was about 8 degrees hotter than the rest of the house. Now, saying like a heater uses a lot of electricity. I will say that the normal breaker can handle about 15 amps. A heater can handle 5 amps. Each printer can draw around 1 amp or so. So,
Let's do the math, yeah.
for me, out of I think there were 10 printers that were active at the time, not 16, but it's like 10. 3 of the printers did not have power outage, but basically three completely died from the print. I had to scrap them. The rest of the 7 printers, I could start again, and it remembers its position in its EEPROM, right? It's a erasable memory chip. And printers that have that, what they can do is if the power cuts out, they can resume printing after it's been turning on. It's an amazing feature. But remember that if the printer loses power and it turns back on, it might not know where it is. It's like in a gray area, right? It only knows where it is from the moment it's been calibrated. And after that, even if your power off and you turn it back on, it just guesses. So sometimes this may happen if you have a power outage, unfortunately.
My printer doesn't have power outage protection. At that point, I'm just kind of like, I just get mad at it.
You yell at it and it fixes its problems. Yep. Ooh, salmon skin. Salmon skin is the phenomenon in which I guess your prints aren't accurate enough, like layer by layer. So you get something like this happening in which it's like rubby, like a salmon. It's hard to fix. It's one of the hardest things to fix in a print.
If you just have a bad printer, it's just not gonna move.
Yeah.
Because if you don't have okay, so Ender's work in something what's called reality magic numbers, because that's like what the guy on Reddit called it. But basically, the idea is that the stepper controller that is within the stock Enders is so bad that you have to work within, so we can define layer heights, right? So that's the amount of, like per layer per height kind of thing, right? Higher layers, bigger, more gappy, kind of salmon skinny looking stuff, but lower layers, meaning that it takes more time to print, but it's going to look a lot more smoother because you're doing more passes per millimeter kind of thing, right? What can happen is with the creality system, if you try to give it a step number, that is not divisible by 0.004, the motor will skip because the driver is so bad that it will literally try to make up for this distance that it doesn't understand, right? It's like trying to say okay, my printer has a certain precision that says okay, my precision on my layer height is 0.001, for instance, millimeters, okay? Whereas the crealities are 0.04 millimeters, meaning that if you give it any kind of number in between, that's something that is not divisible by 0.04, the printer is not going to take account for that. It's just going to print whatever is closest to that. So the more money you spend, and I'm going to say this always, the more money you spend, the better it becomes. And that is literally one of those examples where you have a system that doesn't have the precision to print what you want it to, right?
Yeah. The printer says, I'm going to do a little rounding, and that's what you're going to
Yeah, I'm
get.
going to do a little bit of rounding, and that's it. Yeah, and the rounding is bad because that also leads to layer shifting, sand and skin, and all sorts of stuff. It just looks terrible. I mean, like I've seen it, I've lived it, now move on.
Yeah.
Okay.
When you get to the escape room, you'll be able to see some of the prints. Oh, check out the door that to the room, basically the thing that's locking you in. The door is printed using an Anchor Make M5. There's like zero sound skin. It's beautiful. It uses like the newest chip drivers. Compared to like maybe some of the other things in the room, like boxes or the puzzle you're gonna solve, it might not have the best quality because it's printed on like lower tier printers. So you can just do a little bit comparison in the room and check it out. But like the door was printed using Anchor Make M5s. So it's good stuff, yeah. Okay, I'm not going to go over Slicer Guide too much because I know we're running low on time. But here's some terminology that you can look at it later if you want. This is one of those overhang tests.
Yes,
It's pretty fun.
bridging, another art form.
Yeah.
Bridges.
Oh, I love this.
Is that yours?
No.
Oh.
You asked this last time.
I always have a bit of a hard time.
Yeah, so this is a CR30, and this is what happens if you don't get your settings right. This is called spaghetti. And it's pretty much just when filament just does whatever and off the print, and it ends up looking like this.
That's a lot of money.
Yeah, this is like about...
That's like $10.
Yeah.
Probably. That sucks. That's a bad day.
So even if you have a printer, you can attach a camera to it to see what's going on at all times, even if you like leave the workshop.
There's systems now that use like basically like algorithmic AI things to understand when spaghetti has happened and it doesn't auto stop. It's actually kind of cool. I've never used it, but but
Yeah.
some AI is like, I don't want to print right now.
Yeah. All right. I'm going to stop it for here, and we're going to discuss some escape room stuff for now. Are they ready? Are they ready? All right, we're gonna do a gamble here. So I'm gonna talk about the escape room what we're working with here. Just going to go to our website. Okay. So this is something we're doing for the first time, and whether it works out or not, it's probably going to be the last time, or depending on if they do it next semester.
No judging.
It's a first time, basically first time, but for the last time, and I don't know if they're going to do this next year. This is the only thing you're going to experience. So we did a test run of this yesterday, and it kind of worked. Yeah.
We'll take kind of.
Okay. So what's going to happen is we're going to break you out into groups. We have 5 rooms presumably set up. This escape room took about 2 weeks and 5 really skilled engineers to pull this off. And there's a bunch of puzzles in the room. He was one of them. There are 7 puzzles you must solve. Basically, we took 7 things out of the printer, and you have to find those 7 things in order to get it working, right? So we're going to lock you in a room. Basically, the lock is just a cover we put on the door handle to prevent you from escaping. Don't break it, please. Yeah, it takes a long time. And like actual escape rooms, people who spend like their lifetime on this have the money to be able to do 1 room. We're doing 5 in parallel, so it's going to be a little bit difficult. We're going to put you in a room, lock you up, and there's going to be a broken printer in there and a guy who is smart enough to fix it for you, but he won't. That's known as the Game Master. You're going to get 7 things in the room that are locked up, and you have to solve puzzles to get them. The puzzles can literally be anything, so keep your eyes peeled. Be curious. There are things going to be hitting around the room that may be clues for you to solve. Now, if there's anything that's already there, like this clock here, we're not going to hide anything behind it. So you don't have to check that. There's nothing that's going to go on with like stuff like this, like the pencil sharpener, that's not there. Nothing on the computers, nothing everything. It's all going to be very obvious and out in the open for you to look at. So just go ahead, be creative, find out what you want, and go with that. So after you find the 7 things, you're going to repair the printer with your Game Master. Print out the key. One of the 7 things is going to be an SD card that you will have to go ahead and insert into the printer to print the thing, and then escape. Now, couple rules. Rule number 1, don't break things. We very well know you can like just kick the door open and it'll work, but that defeats the purpose of the game. So please don't do that. Yeah. So don't Don't kick the door open, please.
I don't know.
Yeah. Second thing is don't tamper with whatever's already in the room, because we're doing this in classrooms. We're not actually doing this in a themed escape room. And rule number 3 is if the game master says you can't do that, don't do it. They're there to protect you. They're there to protect the printer. They're there to make sure you don't get hurt. You get 3 clues if you get stuck on a puzzle. The game master will not directly tell you what to do, but will nudge you in the right direction. And if you get stuck within the 2 hour, oh, by the way, did I mention there was a 2-hour time limit? There's a 2-hour time limit. So if you don't get out by 2 hours, well, there's a story behind it and everything. You can probably read it, but I also have an intro video I recorded. So you die, metaphorically. So, yeah.
Got it all. Sorry, guys.
Yeah. You might notice that there will be a few people coming in and out of the room. The room is openable from the outside. They're just going to be there for filming purposes. They're going to be there to just, create like a montage of everything that's happening. Yeah, spectate. Just assume they're like ghosts. And then also, if anything happens to go wrong inside the escape room, which I think there will be things that will definitely go wrong, just try to go with a flow. I don't have the 100% confidence on the keys that will be printed. If you print the key and it ends up not working, each of the game masters should have the respective actual key to that room, so you're not locked out forever, and they'll just give you that.
Be gentle with the recipes because there is a known issue that we have with that.
Yeah, if you twist them hard enough, they may get stuck in the lock.
If it's not turning, it's probably not right.
Yeah. Yeah.
Because so don't do that.
Yeah. Okay.
If you think you can bring it better, probably can't.
All right. So we've gone over the rules. Are there any questions as to what you're going to do in the next 2 hours? This is the first time we're ever doing this, so it's exciting.
Yeah.
Okay. Let me go over the story. So there is a story. It's an escape room. There is a story. I wrote a story. It's right here. Anyways, you and your team are exploring an abandoned makerspace. And you and your team have gone in the door, and it slams behind you and locks. And the locks is apparently a cover to the door, so don't mind that. You know that the abandoned makerspace will basically be demolished in about 2 hours, and you still choose to go in the room. Yeah, so basically it'll blow up in 2 hours, and if you don't escape, you'll get blown up with it. The only way to escape is to follow the engineer's notes that they left behind. They also left behind a broken 3D printer and just like a lot of stuff hidden around the room. So you need to go ahead and fix the 3D printer, print out the key, and escape before the 2-hour time limit is up. All right? Hey. It's the best I can come up with in 2 weeks. Yeah. All right. So we are going to go ahead and divide you into teams now. I'm going to stop the recording for those of you who are watching. Thank you for watching, and I'll see you next week.